Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Multi-Agent Systems. When AI teams collaborate to solve problems. Imagine you're building a super complex app. Would you make one giant chunk of code do everything? Probably not. You'd break it down into smaller, specialized modules. Multi-agent systems. MAS. Apply this same idea to AI. Instead of one super AI trying to solve a huge problem, we have a team of smaller, specialized AIs called agents working together, just like different people on a project team. Think about building a house. Can one person do it all? Design, plumbing, electrical, construction? It would be slow and hard. Similarly, a single AI might struggle with very large, dynamic, or unpredictable problems. Multi-agent systems allow us to tackle these challenges by dividing the work. Each agent focuses on what it's good at, making the whole system more efficient and capable. Much like your back-end team handles data while your front-end team handles the UI. In a multi-agent system, an agent isn't a human, but a piece of software, or sometimes hardware, designed to do a specific job. Think of it like a microservice or a component in your code. It has a goal. It can perceive its environment, take in data, make decisions based on rules or learned patterns, and then act upon that environment. For a developer, an agent is essentially a module or object in your program that has its own encapsulated logic and behavior, ready to be deployed. A team isn't a team if members don't communicate. In MAS, agents need to talk to each other to share information, coordinate actions, or even negotiate. This isn't literal talking, but rather sending messages or data. As a developer, you'd implement this using APIs, message queues, shared databases, or custom communication protocols. Agent A might tell Agent B, "I found this data, can you process it?" Or, "I'm doing this task." So you don't have to. Just like human teams, AI agents can collaborate in many ways. For example, 1. Divide and conquer. Break a big task into smaller pieces, and each agent tackles one piece. E.g., one agent scans for errors, another corrects them. 2. Expert system. Each agent is an expert in a specific domain, combining knowledge to solve a problem. E.g., a medical diagnosis system where one agent knows about cardiology, another about neurology. As a developer, you'd design the rules and protocols for these interactions. Multi-agent systems are already at work. You might find them in traffic management, where agents representing cars or traffic lights coordinate to optimize flow. Logistics and supply chains, where agents manage inventory and optimize delivery routes. Gaming, where non-player characters, NPCs, act as agents, interacting with the player and each other. They make complex, dynamic systems more manageable and intelligent. Why go through the trouble of building an AI team? The benefits are huge. Multi-agent systems offer robustness, meaning if one agent fails, others can often pick up the slack, and the whole system doesn't crash. Scalability, allowing you to add more agents to handle more work as the problem grows. Flexibility, as agents can be added, removed, or updated independently without rebuilding the whole system. These benefits are crucial for complex, real-world applications. As a developer, if you were to approach a problem with MAS in mind, you'd start by 1. Decomposing the problem. What are the smaller, distinct tasks? 2. Defining agents. What role would each agent play? What data does it need? What actions can it take? 3. Designing communication. How will agents talk to each other? 4. Establishing coordination. Asterisk what rules govern their collaboration. Frameworks and libraries exist to help, but understanding these core concepts is your first step towards orchestrating your own AI ensemble. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.